Hi, I am Ahmed Hany, and I am going to do the introduction for our project, Huawei Alarm. Okay, our project basically is an alarm, but the problem with the normal alarms is that it's static. It's always beside your bed. So when you wake up while you are unaware, you may snooze it or even turn it off. So you're gonna miss your meeting, university, or anything. The idea of Huawei is that it's an alarm in the shape of a car. So when you activate it, after a certain while, when you want to wake up, it's not only buzzes, it also lights, and also it will move all around in your room and avoid obstacles. So you have to go on of your bed to get out of your bed, run after it till you catch it. So you have to do activity. So we are guaranteed that you can wake up.
Mahmoud Mohamed, 34-15954. We use ultrasonic sensor for detecting obstacles, and also we use 2 infrared sensors instead of buttons, and reduced its sensitivity, so when we click on it, the car will move and act like buttons. And here we used an adapter for reducing 9 voltage for each bridge, and each bridge conducting the voltage to the motors of the car. And also we used the flame sensor. When it detects fire, the buzzer will alarm, and the LED will light.
So we'll start with the hardware connections. For the port source, we have the adapter. The input is 220 voltage AC. It outputs 9 voltage DC, and we connect it through this socket. Just to get the positive side and the ground. Then we connect the VC and the ground to the edge bridge. Also, we connect to the edge bridge the output of the. We connect the VC from the edge bridge to the Arduino VN in order to not have to connect another power source to the Arduino. Okay, for the edge bridge, actually it connects these 2 wires, provides the motors with motor 1 and 2, and the other for the right and the left motors. The motor. Okay, the idea of motor 1 and 2 is that the difference of these two inputs decide the direction of the wheel. Okay, either it will go forward or backward. Okay, and these inputs are the control coming from control signals coming from the Arduino. Okay, for the ultrasonic sensor, the ultrasonic sensor have 4 pins: the VC, the ground, the triggers that actually that's an input to activate it, and the echo, which is actually the output that we get from the sensor, and we get it to the Arduino to process it and decide upon it if the wheels will go the direction of the wheels. Okay, coming for the 2 sensors, the 2 sensors have to get the VC and the ground right here. Yeah, and the 3rd pin is the output. The outputs of these 2 sensors are connected to the Arduino, and upon it we decide if the whole thing will work and not, as we will see in the coding part. The flame sensor also gets the VC and the ground and the output. And right here, I needed a big node, to have the ground and the VC in order to connect all these things.
I'm Hazem. I'm going to walk you through the code of our project. So if you have a look, first we're defining some constants, simply some inputs and outputs on a breadboard. This is a trigger that activates the echo sensor. This is the input of the echo sensor. These are the outputs for motors. These are the inputs of the sensors, the infrared sensors. And this is the output for the buzzer and the LED, and this is the input for the flame sensor. Okay, first our setup method. We set some inputs and outputs. For example, the trigger for the echo sensor is an output. The input for the echo sensor is an input. Both sensors are set up as input, of course. The motors are set up as outputs. The buzzer also, and the LED. And the flame sensor is an input. And here we are beginning a serial communication just for debugging. Actually, can I move this line? Won't cause any problems. Our loop method, the main code. Okay. So we're getting a digital lead for both the sensors, which are the infrared sensors that are acting as buttons instead of buttons. Okay, so first we digital write hello on the trigger, and then we wait for 2 microseconds, and we write 1 on the trigger again to activate the echo sensor, and then we wait for 10 microseconds for it to work. And then we write 0 again, and now our echo sensor is working. So we take a pulse in of the echo sensor, okay, and we calculate the duration, and to calculate the distance, we multiply by the speed of sound in the air and divide by 2 to get the distance. And then we check if X is the digital read of sensor 1, which is activate sensor button, and there's no fire. We have a delay of 3,000 milliseconds, and then we set R to 1. Else we set R to 0. Okay, let's skip this part for now to walk through the flow when the button gets activated. If the button gets activated, so R equals 1, we check if the distance. We check if the distance is less than or equal than 40. We flip the output on the left motor 2 and the right motor 1, so that the car will stop and will turn. Else, if the distance is greater than 40, the car is working normally, high on left motor 1, low on left motor 2, and the same for right motor 1 and 2. And we enable the buzzer and the LED for the alarm to work, for it to make sound and turn on the lights and so on. So we digital write on the buzzer and the LED digital ones. That's it. Okay, so let's see if R equals 0. If R equals 0, which means that we either did not activate the sensor number 1, or if we activated and then activated the sensor number 2, which is going to make X1 0, we set R equals to 0. So we go in this else part of the code, which turns off the motor, so the car does not move. And we check again for the flame flag. Okay, so the flame flag, okay, here we got the input flame sensor from the digital read flame sensor. And we check if it's equal to 0, that means that there is actually a fire. So we set the flame flag to true. And then here we check on the flame flag, and here we check on the flame flag. Here we check on the flame flag in order to make sure that if there is a fire, even if the alarm is not working and the car is not moving, it detects fire and it activates the buzzer and the LED. And here we had to include this part of the code in order not to deactivate the flame sensor as long as there is a fire if the car is working. So we have to before turning of the buzzer and the LED if R equals 0, which is going to stop the whole car and the LEDs and the buzzer. We have to check first. If there is a fire, then the LED and the buzzer have to stay activated. That's why we check before turning them off. And that's it.